All right, so very first thing we're going to do with this one is we're going to do a little bit of factoring review because it never hurts because, again, factoring keeps popping up as we go along with some different things. So we're going to keep reviewing on this one just to make sure everybody's good. So. Okay, and again, this won't be a very long factoring review. Just the more we see it, the easier it gets. And again, there will be more factoring coming up later on. So just want to make sure everybody's good with that one. So first thing we're going to do with some of the factoring review, we're going to do a difference of perfect squares. Okay, so difference of perfect squares. Again, the big thing on that one is that if it's x squared is x times x, 36 is 6 times 6. As long as it's the subtraction and you've got two perfect square numbers, it's something times itself and something times itself here. That basically what we're going to do for that one is that's going to be x plus 6 and then x minus 6. All right, now where it gets a little bit more complicated with some of these, and again, just going back and reviewing on some of these. If it was 4x squared minus 81, but if they throw an extra variable in there, make it like y squared, it's still, going to be basically the same thing on this one. That if you've got 4x squared, that's, again, if it's x squared, it's still x times x. But because it's 4, it's 2x times 2x. 81, would be 9 times 9. But because it's y squared, we just need a y and a y. So if they give you an extra variable, you just have the extra variable tacked onto the number there. Okay, so all we're going to do is because the 4x squared is first, we're going to put a 2x first. And then the 9y would go second. One's going to be a plus and one's going to be a minus. Okay, so just remember that one. And again, that's just some different things there. The other thing we've got is we're going to do one more of these just to kind of show you something on this one. It's a little bit of for doing the full method. And again, when we do the full method, that's just a double distributed property, as you're going through these. That if basically if you do something like this, there's one shortcut that we get to do. That if they give you something squared, whether that's a plus, and we'll show you like an example of like one in a second. But basically, they always say if it's something squared, doesn't matter what these two numbers are, it's always going to be the first thing squared and the last thing squared. In the middle, it's always going to be 2 times A times B. So as long as it's something squared, again, it's the first number squared, the last number squared. And in the middle, you're going to do 2 times this times this. Okay, so I'll give you one that's more like what we're going to see. It's x plus 4 squared. Okay, so first number squared, then we're going to have the last number squared, and then in the middle, it's 2 times these two numbers. So it's 2 times x times 4. So if you've got 2 times x times 4, really it's 2 times 4, so that'd just make it 8, and then times x, and then 4 squared is 16. Okay, now, and I say that because in some of the homework problems we're going to do, they may ask you to do something like this, where you're going to do x plus or x minus something squared. If it happens to be that this is a minus that's here, the only thing that would change if this was a minus for this part instead of a plus, you would change the middle number from a plus to a minus. So whatever the middle sign is here, the middle sign will stay here. This will always be a plus at the end of it there. Okay, so in the homework, if they happen to give you one of these where it says to do something like this and they ask you to expand it for this part, go ahead and do the full method because that will go really quick on these. Where we're going to do the longer part is if they ask you to expand using the binomial theorem. This is where we're going to actually do something a little bit different for this one. Okay, so we're going to do something like this. We're going to do x plus y to the sixth. And I know a lot of times we don't like it if it has just variables on it. This is actually one, when you get this one in the homework, this one's actually easier than the other problems. So we're going to use this one first because this is actually the easier one. And then we'll show you the other ones that get a little bit harder as we move into those. Okay. Okay, now again, I do not want you to do the full method over and over and over and over because that will take you forever. You're not going to be very happy and you're just going to quit because nobody's going to like that one. So here's where we're going to go back to this thing. Here's where we're going to use this handout we've got. So it says the very first thing we're going to do is we're going to write the row of numbers from Pascal's triangle where the exponent is the same thing as the second number in the row. So for this one, our exponent is 6. So we've got to use the Pascal's triangle that's got a 6 in it somewhere. Well, it's going to be this one, right? So the very first thing we're going to do is we're going to write down these numbers. Now, as you're doing these, I won't put this on a separate piece of paper because there's not enough room here to do this one. So I'm going to go over to the next piece here. Don't just squeeze it in tight when you do this one. Leave plenty of room because this is one of those problems where you need a lot of room to do this one. So we're going to go back and use the row of numbers that's got a 6 in it. So that's the 1, 6, 15, 20, the 15, 6, and 1. So that's got a 6 exponent. So we're going to use the row of numbers that's got a 6 in it. Okay, so when you write down those numbers, spread them out a little bit. Okay, so this power, again, it's always the second number because the first numbers are always 1. So we're looking basically for the second number that's here. All right, so step 2, it says now we're going to take the very first term we've got, which in this one is the x, and we're going to write it in descending powers underneath this one. So this thing is x to the 6, so we're going to start with x to the 6th power. And then we're going to count it down. Then we're going to do x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then x to the 0 power. Okay, so the first variable, you're going to start with this power. You're going to count it down. The second variable, you can either do it one of two ways, which is step 3 that's here. You're going to take the second term, start with the 0 power, and then go up. So then we're going to take y. Now, you can do one of two ways. You can either start with the 0 power and count up. If you want to go to the end, since this is the second number, you can start with y to the 6th and then count it down. So it's 5, 4, 3, 2, 1, and then 0. So as long as you go with 6, 5, 4, 3, 2, 1, 0, this one I kind of go backwards, so you can count it up, or you can start at the end and then count it down. Either way you want to go. If you're a left-handed person, you might like counting down from this one because it kind of might flow a little more natural. Okay, then all you have to do is basically, if you kind of think about these are like columns, then all these numbers kind of line up. And all we're going to do is we're going to take these answers and just write the answers out underneath it. So we're going to multiply everything in here together. All right, now, and if you notice at the bottom here, note number 1 says, anything raised to the 0 power is 1. So where we've got a 0 power here for this one, you can just scratch that out and put a 1. We got a 0 power here. You can scratch that out and put a 1 there. So anything with a 0 power, just scratch it out and put a 1 because that's really what it is at that point. Okay, and then you're going to multiply everything in here together. It's 1 times 1 times x to the 6, which is, there you go, 1x to the 6, or we'll just put x to the 6th. And then everything else, you're going to write the answer just like it is. This is going to be 6, x to the 5th, y to the 1st. If it's y to the 1st, you don't have to put a 1 there. You can just leave it as y. This one's going to be 15, x to the 4th, y squared. This is going to be 20, x to the 3rd, y to the 3rd. This one is 15, x squared, y to the 4th. This one is 6, x to the 1st, which we'll just put x, y to the 5th. And if we do 1 times 1 times y to the 6th, that's 1 y to the 6th, or in that case, we can just put y to the 6th. Okay, and then that is your answer for that problem. And I guarantee you, if you try to do the full method on that one, you would quit way before you ever got there. I know I'd do the same thing. It would drive me bonkers to try to do that one. Okay, so if they give you the variables, if they give you one where it's both x and y, or a and b, or r and t, or x and c, or whatever it's going to be, it's actually a little bit easier because it's always going to be this row of numbers. And again, these variables you're going to count down, and then these variables you basically count up as you go through those. So we start with 6 x's and no y's, 5 x's and 1, so that's 4 and 2, 3 and 3, 2 and 4, 1 and 5, basically no x's, and then 6 y's as you go through those. So one of them's going up as the other one's going down, basically is what it comes down to. Okay, so let me show you at least one, maybe two with some numbers where it's not just all letters, just to kind of show you how this thing will go. All right, so we're going to go x plus 3 to the 5th power. And if you want to on your paper here where you've got this one, you may want to put a number 19 on this one also, just so that you keep it kind of, so you know where you kind of keep these together, so you know what part goes with what part as we go through this one. Okay, so this one, it's x plus 3 to the 5th power. We've got to find Pascal's triangle. Use a row that's got a 5 in it. So there's our 5 here, so it's 1, 5, 10, 10, 5, 1. So when you write these down, we're going to go 1, 5th power. We're going to go 1, 5, 10, 10, 5, and then 1. Yeah. Again, the way it works is, again, the number that's in the exponent will always be the second number in the list, because the first number is always 1, so you got to look for the second number there. Okay, now and again, this is the part that hopefully should be pretty easy for this one. You start with the first part, the x, and you count it down. It's x to the 5th power, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, Again, this would be x to the 0 power, but we said anything to the 0 power is 1, so that part you can go ahead and just scratch that out and put a 1 there. Okay, now this one, we're going to have to do a little bit more work for this one. So with the 3, we're going to go 3 to the 0 power, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, and then 3 to the fifth. So first term, you count down with the powers. Second term, you start with a 0 power, and then you count up.
Would you still change it, cross out the 3 to 0?
Yep. So then go ahead and cross out the 3 to 0, and make it 1. All right, now, and here's what I would say to do on this one. For these, you actually kind of want to, since we've got actual numbers on the bottom, you actually want to cross out every single one of these numbers and actually figure out what those numbers are going to be. So if it's 3 to the first power, that's just 3. What is 3 squared? What is 3 times 3?
9.
That's 9. To get the next number, now you can do 9 times 3 to get the next number, which would be 27. You do 27 times 3 to get the next number, and then you do 81 times 3 to get the next number there. Good. And again, if you don't know those numbers are off the top of your head, that's where you just take out a calculator, that you start with 1 here, and then you take that answer and you multiply by 3. So we got 1 times 3. Get the 3, then you take that answer, multiply it by 3, then you take that answer, multiply it by 3. So every time you go up a step, you just keep multiplying by 3. If we're up to the 6th power, it would be that. If it was the 7th power, we'd multiply it again. We'd get some huge numbers. We go through those. Okay, and then we're going to multiply all this stuff together. So now it's 1 times x to the 5th, which that one works out okay. That's just x to the 5th with a 1 in the front there. All right, now here's where it's different from the last example. Now we've got 5x to the 4th times 3, so we're going to do 5 times 3 to make it 15, and that's x to the 4th. So now we've got 10 times 9, which will be 90, x to the 3rd. 10 times 27 is 270, x squared. 5 times 81 is 405, x to the first power, or just x, and then it's 1 times 1 times 243, which is 243. Okay, and that is a long answer, but that is the answer that we're looking for. Okay, now, and again, the one thing that's always going to be the same is if you start off with x to the whatever 5th power, your answers are going to be x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then no x's. So you got 5, 4, 3, 2, 1, and then 0 x's. The only thing that's really going to change is this number that's in front. And to get the number, that's where we had to kind of do our powers and multiply those powers by these row of numbers that was back up here. All right, one more question, and then we're done. We'll wrap this thing up.
Is that 24?
That is 243 on that last number there.
How'd you get that?
Oh, that we took this 81 that was here and just multiplied it by 3 to get 243. So all we're doing on these numbers is that with everything in here, once you've got, we know this 3 to the 0 power is 1, because the base number is 3, we're going to multiply it by 3.
Oh, I didn't add it.
Okay, all right, gotcha. So yes, then we're doing 3 times 3 to get 9, 9 times 3 to get 27, 27 times 3 to get that, and 81 times 3 to get that.
Mm-hmm.
All right, one more, and we'll wrap this thing up. All right, so for this one, we're going to do x minus 2 to the 4th. All right, and for this one, don't worry about the minus sign. We'll talk about that one at the very end. we're still going to do the same thing. It's x minus 2 to the fourth power. So we're going back to Pascal's triangle, find the numbers that's got a 4 in it. That's 1, 4, 6, 4, 1. So we're going to pull down those numbers first. So we got 1, 4, 6, 4, 1. And again, the big thing is on that one, spread them out. Don't leave them close together. To actually spread these things out so you got plenty of room to work. Okay, so for the x, we're going to count it down. X to the fourth, x to the third, x to the second, x to the first. And on this one, if you want to put x to the 0, if you want to go ahead and scratch that out and just make that a 1, that's okay. Okay, so again, with the first one, we're going to count it down, 4, 3, 2, 1, 0. With the 2, we're going to do the opposite. We're going to count up. We're going to go to the 0, to the first, to the second, to the third, and then to the fourth. Okay, and then we're going to actually kind of figure out what these numbers are. Okay, so 2 to the 0 power. I said anything to the 0 power is 1, so we got that part. To the first, well, that's just 2 to the first power, so that's just a 2. To get the next, and again, from here, we'll just keep multiplying by 2. 2 times 2 means that's going to be a 4. 4 times 2 is 8. 8 times 2 is 16. Okay, and it always starts off the same way. This starts with 1, and then whatever this number is, that'll be your next number, and you keep multiplying by this number over and over. So it's 1 times 2, 2 times 2, 4 times 2, 4 times 8, or 2 times. Just keep multiplying by 2 as you go through those. Okay, so we've got 1 times x to the fourth, which is just x to the fourth. Okay, so now we got 4 times 2 for 8, x to the third. And then the only catch on this one is that when we do with a minus sign, so if the expression has a minus sign, it says the plus or minus signs on the final answer are going to change. They're going to alternate from positive to negative. So you always start with a positive, which means the second number is going to be a negative. The next one is going to be a positive. 6 times 4 is 24. X squared. This one's positive. The next one's negative. 4 times 8 is 32. X to the first, or just x. And then on the end, it's 1 times 1 times 16. And that'd be the answer there. Okay, a little bit long, a little bit tedious, but compared to the other option of doing the full method over and over, it's a better option.